So such they are generally numbers which you have square roots or cubic roots. They cannot be further simplified into rational numbers or integers. So the general rules when we use when simplifying surds or when evaluating them, if you do not understand them, I'm gonna explain them using exponential laws as well. So this first law is when you are multiplying a times b, right? It is the same as or under square root is the same as root a times root b. So this you can be better understood as a times b. You can evaluate it as half to the power half. Oh, sorry, to the power half. So under exponential laws, we know that if we are raising a power to terms in a bracket, that power should multiply each term in that bracket. So which is the same as a to the power half times b to the power half. So this can be further expressed as root of a times root of b. So that's where this law comes into play. So the second rule which we can also use is when it's root a over b is the same as root a over root b. So we'll also use exponents to explain that rule. So root is the same as power half, right? So as long as this power should multiply everything in the brackets, so it's the same as a to the half over b to the half, which is the same as root a over root b. So for this one, we are simply rationalizing our expression here. So we are just moving the square root from the denominator into the numerator. So the way we do it is we have to multiply everything by square root of a over square root of a. So if you multiply everything by square root of a by square root of a, we are simply trying to maintain the expression, because if you cancel this square root of a over square root of a, it's 1. So it's the same as multiplying by 1. Okay, so if you multiply anything by 1, it still remains the same, but this is the same as b over root a and square root of a times square root of a. Okay, so we know square root of a times square root of a is the same as a to the half plus a to the half, and we know by the laws of exponents that, oh sorry, not plus, I made a mistake. Okay, let me just correct. It's a to the power half times a to the power half. We know that by the laws of exponents that if we are multiplying terms with the same base, we add their powers. So it's a to the power half times a to the power half, which gives us a to sorry, not times, I made a mistake there. It's plus. So if you half plus half, it's a to the power 1, right? So this becomes b root a over a. So that's where we get b over root a over a. Okay, this is just factorizing. So root c is just the common factor between these two terms. So you just simply have to factorize. You take the common term between the two. So the common term is root c, and then everything else must fall within the brackets. So if you expand these brackets, it's a root c plus or minus b root c, which is the same as also on the left side of the equation. So if you have a fraction c of a plus b n, p root n, if you want to rationalize it, we have to multiply with a minus b root n over a minus b root n. The reason is because we want to remove the bracket. So the minus like it brings about the difference of two squares. So for example, a plus b root n, if we multiply with a minus b root n, we know like difference of two squares, this is the same as a squared minus b root n squared. Okay, like this is the difference of two squares. Like we can also expand it, it's fine, but we will get the same result. So let's expand it. A times a, of course we get a squared minus a b root n and plus a b root n minus pn b root n squared. Of course these two, they cancel out, so we are left with a squared minus b root n squared, which is the same as this. So it's just the difference of two squares. So what this difference of two squares helps us is that if you square this bn squared, we are likely to remove the square root, because this is the same as b to the power n half squared, right, which is a squared minus because like all in the bracket they should be this power affects everything in the brackets, so it's now minus b squared over n half times 2. So now we have a squared minus b squared to the power n. Okay, so if we complete if we complete this, we are likely to get c all in bracket a minus b root n, right, all over what did we get here? We get a squared minus b squared n, a squared minus b squared n. So that is just the difference of two squares. Okay, let's do a similar problem as well. So for this problem, we don't have a plus sign, we have a negative sign. So if the sign is positive, we have to multiply by okay, let me just, so here we have to multiply by b power n, a plus b root n, a plus b power root n. Okay, if the sign is negative, we have to multiply with positive, and if the sign was positive, as we see here, the sign was positive, we have to multiply with negative, but because here the sign is negative, we have to multiply with a positive. So this brings about the difference of two squares, and we can remove the square root n. Okay, so yeah, the procedure is just the same as we already did, like in this previous example. So we just apply or what's on the top, just simplifying the fraction. So we have c over, this is just the difference of two squares, because like a minus b root n times a minus plus b root n is just the difference of two squares, which here is a minus b root n times b a plus b root n. We'll also get the same result here, which is a squared minus b squared n. So yeah, we'll get the same result a squared minus b squared n. Okay, so let's just add some more. So the other may be a squared is the same as a, because a squared is just a power 2 to power half, which is the same as a power 2 times half, which is a power 1. And the other ones, maybe they may be a root b times c root d, which is the same as a. You just, since this is the same as times, so this is the same as a times root b times c times root d. Okay, so what we have to do is to regroup. You can regroup it times root b times root d, okay, which is the same as ac times, because okay, let me just do it step by step. Root c times b, okay, to the power half times d to the power half, okay, which is a times c times b times d, all in brackets because they are being multiplied by the same power. Okay, so it's just ac root b times t. It's just the same thing. Okay, let's see if we can find another one. Okay, we can have a root b divided by c root t. This is the same as a root b, of course, over c root d. Of course, we can further simplify it as a over c root b over d. Okay, it's just the same thing. Here root out moving from root b to root t is just the same as b to the half over b over d to the half, which is the same as b over d to the half, which is square root of b over t. And okay, 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 also root a squared is also the same as a, because square root is half, and if you square you still get your a. Okay, that's it for now.